Hey y'all, welcome to the second half of my two-part series on adding homing and limit switches to my Gatton CNC. Now I'm going to start this by cleaning up a couple of messes that I left in my last video. Somehow I ended up leaving out all of the footage on connecting up the shielding wires in the shielding cable. And I failed to mention where I got the limit switches or how I mounted them at all. So before we get into the settings in Mach 3 for our homing and limit switches, let me go ahead and clean up those messes right now. Okay, here's a small piece of this shielded cable, and I've gone ahead and I've removed some of the outer insulation so you can see. Now you've got a little bit of a fiberglass filament here to help when it comes time to pull the wire. Then you have this metallic shielding that wraps up the wires. But if you'll notice, besides the red and the black, you also have this bare silver conductor. Now I don't know if you can see that or not, this wire right here. That is the shielding wire that needs to be connected to ground at one end. When you run your regular standard positive and negative cables to where they're supposed to go, this shielding wire, one end of it, needs to be connected to ground also. Now, in doing my research for this, there were a couple of schools of thought. Some folks said, yes, you needed to run this to an earth ground, meaning, a grounding rod driven 6 foot into the ground and then a cable run in and this hooked to it. But on this machine being made out of plywood, we're not talking about lightning strike protection here. We're talking about, voltages. We're talking about basically radio frequency interference. We're not talking about any kind of real current run through this. So all we're doing is we're dissipating interference as it builds up. So grounding this to the terminal strip that I have run down below is just fine in this case. The important thing to take away from this is that this gets connected at one end only. It does not get connected to anything at the other end. If you connect it to something else at the other end, you will create a ground loop and you'll be chasing electrical and electronic gremlins till the cows come home. And those of you who live in areas that are totally devoid of cows, you know how long of a wait that could be. So, connect it up at one end, but do not connect it to anything on the other end. It's there to absorb any kind of radio frequency signal that comes into it and run it down to ground. That's all it's there to do. Okay, for the limit switches, for the mounts themselves, these were sent to me by Andrew Hague over at the Old English Workshop. And he has posted them over on his Thingiverse page. I'll put a link in the description box below to his Thingiverse page where he's put all of the files separately. So you can go download them and either 3D print them yourself or have them 3D printed for you. And they basically consist of these blocks up here, one on the front of the gantry and one on the back edge of the gantry, and then these little bumpers up here, and the switch will come forward and hit against this edge of the bumper and trigger the limit switch. Now this one's for the Y-axis, and up here on the X-axis we have these bumpers mounted to the top of the gantry upright, one on each end of the X-axis. Then we have this switch mount up here. There's a switch on this side and a switch on that side, and obviously those switches will touch these bumpers and trigger the X-axis. And over here is the Z-axis. Now, Andrew also sent me these bumpers to be mounted up here on the top and down at the bottom of the Z-box, so that when the Z-box goes down, this follows it and triggers the switch that would be mounted here. Now I'm not running a lower limit switch, and for the upper limits I chose instead to go ahead and trigger the switch off the top of my tramming plate here. So that's my setup. But these bumpers, the files are over at Andrew's Thingiverse page. Now if you don't have a 3D printer, I will also go ahead and include a link to 3dhubs.com. They're kind of an unofficial registry of people who have a 3D printer that would be more than happy to take on a job like this so that you can get a set of these made up for yourself. So all of those links will be in the description box below. And thank you once again, Andrew. I really do appreciate all of the parts and supplies and these cool motor spacers that you sent me. Now let's get into the computer, get into Mach 3, and get these switches configured and rocking and rolling. Okay, we'll start up Mach 3 so we can get in and get our limit switches set up. Now, the settings here are fairly simple and fairly straightforward. So the first thing we'll do is we'll go up into our config menu and we're going to hit ports and pins. Okay, we're going to make a quick diversion here just for a second and go to motor outputs, and that is just to confirm something. If you look over here, all the way over here on step port and direction port, in my case I'm using port 1. That's because I'm using my parallel port. And this is why we're stopping here just to confirm. You'll want to use the same port that you're using for your motors, okay? That's internal to the computer, and Mach 3 knows to send through that port, and the computer will recognize the signals. That's all we're doing, is just confirming which port on the computer we're using. From there, we'll go over to Input Signals tab right here. And we'll want to go down here on the signal for X++, X-, and the same thing for Y++ and minus, and X++ and minus. Make sure we enter that same port number here. So mine is already set up. Now over here we'll see pin numbers, and now it's time to enter the pin numbers that we physically attached our wiring to out on the CNC. So in my case I have my X run to pin number 11, so I'm going to put pin 11 in the plus and the minus because we're wired in series. Oops. And we'll do here. Then we'll come down to the Y. And on mine I have the Y going to pin 10. And do the same down here. And then for the Z, I'm on pin 12. Now I'm only going to mark the Z++ on mine because I'm not running a Z- limit switch. I'm not putting a limit switch on the bottom of my Z axis. Now from here, we need to look over and make sure we do not have a check mark in active low. And just to clear up a little bit of confusion, some folks don't know what the active low actually means. Active low in Mach 3 means that the circuit is active at 0 volts. Active high means the circuit is active at 5 volts or more. We're running a normally closed circuit at plus 5 volts DC, so we need to make sure active low is turned off all the way across here. We should have red X's all the way through the column. Then here we should also have red X's all the way through the column, all the way down the column, and we should have nothing in the hotkeys. It should be set for 0. That's all there is. Now we can come back over here to this end and we can enable our our X++ limit, our X-, and just go down the line. Do the same thing for Y, and then Z. I'm not enabling the Z-, because I'm not running that switch. Then we'll come down here and click Apply and click OK. We got a reconfiguration e-stop. We'll reset that. Now the next setting will come down here to Config, and we'll click Save Settings. It's important, and I'm going to keep doing this, it's important to remember that Save Settings. That command writes all of these changes to the XML file on the hard drive, so that Mach 3 will remember these settings the next time you start it up. If you don't go into Config and click Save Settings, every change you make affects this session of Mach 3 only. And the minute you exit Mach 3, shut it down, all those changes are lost. So that's one of the most important things you'll do, is click Save Settings right here. Okay. Now we'll go over here to the Settings tab in Mach 3, and we're going to talk a little bit about limit switch overrides. As it sits right now, our limit switches are activated and they're ready to go. If I should drive, say for the sake of argument, the Z-axis all the way up and trigger that limit switch, Mach 3 is not going to let me reset to drive off of that limit. It's just stopped. It's stalled. You're stuck. So we need a way to override that limit switch indication. Now there's two ways to do it. There's the pain in the rear end way, and then there's the easy way. Well, I'm all about easy, but I'll show you the pain in the rear end way first. And that is to come out of Program Run here into the Settings tab. Come down here and you'll see Manual Limit Override. Then you can click this button and you'll see the red LED starts flashing. That means you can now override that limit switch, click Reset, and drive that axis off of the limit. Now you can keep it that way if you'd like, but that simply means every time you hit a limit switch, you're going to have to come in and do that in order to reset that condition and drive off the limit switch. Well, there's an easier way to do it, and that is to come up here. Let me go ahead and reset. Okay. There's an easier way to do that here, and this is Auto Limit Override. Now, Auto Limit Override is the easier way to go simply because if you drive an axis to the limit switch, trigger that limit switch, Mach 3 will automatically override and allow you to click Reset and drive off of that switch. You don't have to come back into Settings and hit Manual Limit Override. It will do it automatically. It still stops the axis. Nothing like that changes. The minute you drive onto that limit, Mach 3 stops the motion of that axis. You will have to come in and click Reset to be able to drive off of that limit switch. Something to keep in mind is Mach 3, the system will not prevent you from driving that axis the wrong way after you trigger a limit. So if you're raising your Z up and you trigger the limit switch, whether you use Auto Limit Override or Manual Limit Override, it doesn't matter which, Mach 3 will stop that axis, let you know you've got a limit switch trigger. Then whether you reset it manually or automatically, it will not prevent you from driving that axis up more. So make sure you drive off of that limit, not onto it further. That's the only warning there. Okay, so we've got a green LED here, an Auto Limit Override. We can go back to the Program Run screen, hit Config, and again, Save Settings. Our limit switches are now set up. They're active. They're ready to go. They're ready for us to test them on the CNC. But we'll do that later on when we test homing and limits all at once. Okay, when setting up the homing switches, we're going to take a slight digression here and talk just a little bit about the Cartesian coordinate system. Now, the Cartesian coordinate system is, for our purposes right now in setting up homing, we just need to remember a couple of things. X is left to right, always. Y on the screen is up and down. Out on the machine, Y is toward the front of the machine, toward the back of the machine. X will always be expressed first. Y second. Z, if it's expressed at all, will be last. Those of you who were in the military and were trained how to read a military map know that you read that map right and up. Cartesian coordinate system is very similar. Motion to the right is always a positive number. Motion to the left is always a negative number, regardless of where you start. So if you have a plot pointed here for just purposes of discussion, and you plot another point back here, you have moved in a negative direction, even though you're still on the positive side of 0 in this graph. So even though you're in positive territory, motion to the left, motion downward is still a negative move. And that'll become relevant here in just a couple of minutes. But I wanted to get that out of the way. For further explanation of the Cartesian coordinate system and how it relates to Mach 3, at the end of the video, I'm going to recommend an excellent video by Mr. Paul Campbell over on his YouTube channel. But I'll get into that a little bit later on. We're going to complicate that matter just a little bit in Mach 3 in that we have two sets of coordinates. Now, some of you have probably seen this and maybe even clicked the button a little bit just to see what it does. When this button is not lit up, we are in our work coordinate system, meaning that the representation over here in our display is of our workpiece, of our work material. When we click machine coordinates, and we've got this lit up around the outside here, you'll notice that my DRO's changed. This is the position, the tool's position in relationship to the entire CNC table. These are the coordinates the machine uses to keep track of itself and know where it is in relation to our homing switches. And that's basically all the machine coordinates care about. The system just is concerned with where homing is, where the home switches are. And this is more or less a set it and forget it type of a deal. Once you set your machine's coordinate zeros, you shouldn't have to ever change them at all unless you're having a problem or you decide for some reason you need to do that. Usually, you will be in work coordinates and you'll rarely, if ever, even be concerned with machine coordinates. But to set up our homing switches, that is important because you have a decision to make. But we'll get into that in just a second. Okay, to enable the homing switches, we'll need to go back up here into the configuration menu and come down here to homing and limits. Now, right off the bat, I'm going to suggest that we ignore the soft limit settings right here. We ignore them for right now. That's another video, that's another topic, and they're not, strictly speaking, necessary to use. They're kind of a luxury. It's a good thing to have, but it's kind of outside of the scope of this video. So we're going to ignore these three columns right here, right now. Also, you'll see here this reversed column. This is used in your motor setup, your initial motor setup. Anything you have in this column right here will not be changed. So we'll ignore this column now as well. What we're going to concern ourselves with over here is home negative, auto zero, and speed. Okay? Here's where you have a decision to make. There are other positions, but to keep this simple, you have a choice to make of whether you want to home your CNC either to the front left corner of the table or the right rear corner of the table. It's 100% up to you. By default, when Mach 3 starts homing, when you come up here and you click Ref All Home when you start up Mach 3, by default, Mach 3 is going to start moving in the positive direction, which means that your Z is going to rise all the way to the top of its travel and trigger the homing switch. Your X is going to move all the way over to the right side and trigger that homing switch. Then your Y is going to move all the way to the back and trigger that homing switch. So if you have red X's down here on your X, Y, and Z, you are going to be homing your CNC to the right rear corner of the table. If you would prefer to home it up to the front left corner of the table, what you'll do is you'll come along and you'll put a check mark here in home neg on the X and home neg on the Y. And that's all. So if you put a check mark here, you are going to home your X and Y axis to the front left of the table. If you shut these off, you'll be homing your CNC to the right rear of the table. Once you get this set, again, this is usually a set it and forget it type of a deal. Unless you change your mind later on and decide, you know what, I made a mistake, then you can come back and change these. But normally, you'll only set it up this one time. So for me, what I want to do is I want to home my CNC down here. I will go ahead and leave both of these. No, I will go ahead and I'll check home neg on both of these. Now I want my Z-axis to home to the top of its travel. That's a positive number, so I will leave that unchecked. Auto 0. We're going to go ahead and put a check mark in all three Auto 0 boxes. And the reason for that is when we click Ref All Home, our machine coordinate DROs, once my Z-axis moves all the way to the top and triggers that button, it will back off of that switch until the switch disconnects, then set my DRO to 0. Then it'll move on to the X-axis, move it over into the left until it hits that switch, back off a little bit until that switch disengages, then set this DRO to 0. And it'll do the same for the Y. Move all the way to its position and engage, then back off of that switch, then set this DRO to 0. You want it to go ahead and automatically zero these DROs. Speed percentage. When you click Ref All Home, the first thing that's going to happen is your Z is going to start moving first. This percentage is the percentage of your velocity settings that you have when you set up your motors. So in my case, for instance, I have my Z set to where my rapids are 120 inches per minute. Now, I know it's a short axis, it'll never get up that high, but that's the maximum amount that it's allowed to go. With my percentage at 20, which is the factory default, it will take 20% of that number. So in other words, when my Z starts homing, it's going to start moving up, in my case, at 24 inches per minute. Conversely here, my X and Y, I have the rapids on those set at 200 inches per minute. 40% of 200 is 40, so they are going to move at 40 inches per minute. So 20 is the factory default. I see no reason to say change that. 40 inches per minute is not so slow that you'll be able to read a book while it's homing, but it's not so fast that you're going to damage a switch or damage an axis when it makes contact with that switch. So I'm going to go ahead and leave these numbers as they are and click OK. All right. Now we'll go back up into Configuration menu, go to Ports and Pins, go over to Input Signals, and now we'll take our X home, turn it on. We'll go to Y home, turn it on. We'll go to Z home and turn it on. So these are now enabled. But we now have to tell it which pin number we're working on. And this will be the same as your limit switches. So in my case, I'll be doing 11 for my X, 10 for the Y, and 12 for the Z. And we are enabled across the board. Once again, active low turned off all the way down the column, and emulated turned off, hotkey 0. What am I doing here? Activate that. Okay. All right, so we've got our port, we've got our pin number, active low shut off, emulated shut off, nothing in the hotkeys. We'll go ahead and hit apply, then OK. We'll go into a configuration reset. We'll go ahead and clear that, then go back to the config menu and save settings again so that it writes those changes to the hard drive. Okay? Now, this next setting I'm going to show you is probably the single most important setting that we've got in Mach 3 for this. Now, in my case, my CNC is oriented to where my gantry moves on the Y-axis. I have a master motor and I have a slave motor. In my case, the A is slave to the Y. The way I have it set up right now, I only set, let me go back in here and show you, ports and pins, input. I have done nothing with the A axis down here. There are no ports, there are no pins, there are no nothing. We don't want to confuse the system. But we want that A axis motor to turn when our Y axis turns. So, reset. We'll go over here to config, general config. We'll come down here in the center in the general configuration corner, go right down here to this little setting, home slave with master axis. And we'll put a check mark there. If you do not put a check mark here, when you go to home this axis, your master axis motor will start turning, your slave motor will not. You'll start to hear creaking and cracking and rip that gantry apart if you're not fast enough on that emergency stop button. Putting this little check mark here homes the slave motor with the master motor on that axis. This is probably the single most important setting that you're going to set. Make sure you do that. Whatever axis your gantry moves on, you want that slave motor turning with that master motor. Now we're going to do something else. Since we're in this screen right here, we're going to come up to input signal debouncing and noise rejection. Okay? Now, bear with me a second here. You electronics guys already know about switch bounce and what it is and what to do about it. For those of us who are not electronics guys, I had to look into this and figure out what it means. Basically, signal bounce is when you flip a switch, to you and me, it feels like a positive, definite switch. The switch clicks and the circuit is just closed. Inside that switch, however, there could be anything from pitting on the switch reeds to some debris in there or what have you. And even though we feel that secure positive click, the reeds in the switch are actually bouncing just a little bit. And that can take, just a microsecond or two for that bounce to indicate. But the system is reading it as 2 engagements of the switch and not 1. So we'll need to filter that out. And at the same time, we'll be filtering out spikes of RF interference. And the way we'll do that is we'll come up here to our debounce interval. and we're going to change this to 1,000. Now you see this over here times 40 US. US is a symbol for, in this case, microsecond. And a microsecond is a 1/1,000,000th of a second. So what we're setting this for is any spike in signal through the cabling on our switches, or any kind of a switch bounce, will have to be longer than, in our case, 40,000 1/1,000,000ths of a second. Now, I know it sounds like I probably sound like Charlie Brown's teacher to some of you non-electronics folks, and I sound that way to myself too. But what this does is this filters out any kind of a spike in RF interference or any kind of a false indication from other forms of interference, or even just a crummy switch. By delaying that initial pulse of current, or drop in current, or a pulse increase in current through that cable. Now, in researching this and checking it out, it was recommended that 1,000 is a good number to start with here. If you start getting false limit switch triggers, or even false e-stop triggers, generally, if you can find no problems, no physical mechanical problems, the switch is good, the wiring is good, you don't have any other troubles, adjusting this number here is a way to filter out interference that are causing the false positives. 1,000 is the recommended starting point. You might have to adjust it up if it keeps happening. Some of the folks that I talk to in some of the forums, they have theirs up in the 7, 8, and 9,000. The overwhelming majority are sitting at 1 to 2,000. So it's generally accepted to start with the lowest number first, which would be 1,000. And if you keep having false e-stop or limit switch triggers, come back and adjust this if everything else checks out okay. So the short answer to the long story here is put a check mark in home slave with master axis and put your D bounce interval to 1,000. We'll click OK. We will once again come up to Config, Save Settings. Now we'll restart Mach 3. After we restart Mach 3 and get it opened back up, we'll go over to the CNC and we'll test our limit switches. Then we'll test our homing switches. Okay, out here in the shed on the CNC, we're going to give you a Mach 3 view of all of this first. Now, I know I'm using a different screen set than most of you probably have, but the screens are going to be basically good enough. They'll be similar enough to where you'll be able to follow exactly what I'm doing. The appearance may be a little bit different on your screen than on mine, but everything remains the same. I've got the computer fired up, obviously. I've got my controller turned on, and everything is all set and ready, and we're getting ready to test the switches. Now, the first thing we want to do before we go any further at all is come over here to the Diagnostics tab in Mach 3. And in this screen, the area we're looking at is right up in here. You'll see in this column here, you have M1 plus limit. Then over here we have M1 minus limit. Then M1 home. In this case, M1 stands for motor 1, M2 stands for motor 2, M3 motor 3. Those are what we're concerned with here. We have the plus limits, the minus limits, and the homing. You'll notice these rows here, there are no LEDs turned on. There are none turned on at all. That's the way it should be because none of my switches are engaged. If I engage the Z limit, you'll see motor 3 lights up yellow, and the plus limit and the M3 home. I also get a reset because that's a limit switch. So I can come down here, click reset, and we have no LEDs showing, at all. If you have an LED showing in this screen and a switch is not activated, if you're not on one of your limits, and you have an LED lit up over in this area here, get in and check it out. Go back into your config ports and pins. Make sure you have active low turned off. Then if that makes absolutely no difference, go check your switches, check your wires. You've got a short or something there. These LEDs will light up when there's zero current running to them, because we are running a normally closed circuit. So if we're clear here, we've got no LEDs lit up in this screen, we're ready to go ahead and test. I'll go back into my program run screen, and I'm in work coordinates. You see I've got a little light here that says machine coordinates are on, or when it's off, we're in work coordinates. So I'm going to test all of my limit switches right now. And the first one I'll check is the Z, which I know works because we just tested it, but we'll check. Went ahead and clicked it. We've got limit switch triggered. We've got the reset flashing and emergency mode activated. So I'll come down here and hit reset. Now I'm going to check my X on one side here, and I got a limit switch trigger. So now I'm going to reach up here and do the other side of the X, and I got a limit switch trigger. Okay, now I'm going to check the Y. This is on the front of the gantry. We have a limit switch trigger. And I'll check on the back of the Y, and we have a limit switch trigger. So we know our limit switches are set up correctly, they work, and they are ready and raring to go. Just to confirm, I'm going to go ahead and run my Z up and trigger a limit. So moving up, getting close. And there we go. The Z axis stopped moving. I got a limit switch trigger. And now I'll go ahead and click reset. And because I set that at auto limit switch override, I can go ahead and reset it and now drive my Z down to disengage that switch. So I'll go ahead and I'll do that on the X and the Y also, but we'll move the camera so you can see what I'm doing. Okay, let me start off by saying there's no real good position for the camera in here, so pardon my back, okay? Now, I've purposely set my X-axis way over, and I'm going to go ahead and I'm going to drive it onto that limit switch just to test it out, and we shall see. Okay, I ran it onto the limit. The axis stopped moving. I've got a reset here. It's triggered a reset, so I'll go ahead and reset it and drive it off the axis. Okay. I'll go ahead and test my Z. Whoops, wrong one. And there's my Z limit switch triggered. Go ahead and reset and drive it back down. Okay, and the same is true with the Y. I won't bore you with the details. I've already tested the Y. I know they work. So now it's time to test homing. Knowing that I have good X, Y, and Z switches on here, we can do a ref all home on the screen, meaning I will just click that ref all home and let it do its thing. Now, because it's only moving at 40 inches per minute, I'm going to go ahead and pre-position them, get them a little bit closer. because I know my X is going to move in that direction. There's no sense in waiting for it to move over there all the way at 40 inches per minute. Same is true with my Y. I know it's going to home to the front. There's no sense in waiting for it to get all the way over there. So now I'll step in, click Ref All Home in Mach 3, and we'll let it do its thing. I'm switching over my DROs to machine coordinate and click Ref All Home. My Z goes up. My Y comes forward. And my X moves to the side. And all of my DROs in machine coordinates have reset themselves to 0. This is my machine's home position. Now I'll move the camera, let you have a shot of Mach 3 while I home it one more time. Okay, again, because we have such close quarters in here, you may see the Z or the X moving. But if you can see over here on my screen, I'm now in machine coordinates. I've got an LED lit up here. My DROs are set to wherever the machine is. I'm going to go over here and click Ref All Home, and we'll watch Mach 3 move and reset all my DROs. So Ref All Home. The LED turns red on the Z moves. Now the Y. Now the X. And there's my router getting very much in the way. But now you see what's going on. Let me back this out of here. With the exception of my Y, which I just moved, in machine coordinates, I have Z0, I have X0, and I've got green lights all the way down. That tells me that everything has been zeroed this session. I'll switch back over now to work coordinates, and we're ready to go ahead and load a project, load some G-code, mount the work material to the table, and go. So with the homing and limit switches tested, we can put this one to rest. I'm going to call that the end of this video. Now, as promised earlier, I'm putting a link in the description box below to the channel of a gentleman by the name of Paul Campbell. Now, Mr. Campbell has created some extremely good videos on setting up homing and limit switches that go much further in depth, and both hard limits and soft limits on his limit switch videos. Then in the homing, he starts getting into offsets and using fixtures with your CNC. So I highly recommend you checking him out. Again, I'll put a link in the description box below to his channel. It's really worth the time. Well, I'd like to thank you very much for watching what turned out to be another extremely long video. Y'all really have the patience with me, and I appreciate it. If you got anything out of this long old thing, please give me a thumbs up down there. I really do appreciate the thumbs ups. And if you want to keep following along, I've got a couple more things to do to my Gatton CNC before I can start cutting on it. Consider subscribing to my channel. Whether you subscribe to me or not, again, thank you very much for taking the time to watch this, and y'all take care.